This video is going to show you the relationship between sine and cosecant and direct you into graphing the cosecant graph to add to your packet. You have already completed graphs of sine and cosine. We're going to simply sketch in the sine graph here. You can refer to your earlier graph if you wish. We know that the sine graph begins at the origin. By pi over 2, it has reached 1. At pi, it has returned to 0. At 3 pi over 2, it is at negative 1, and then it returns to 0 at 2 pi. So we're sketching it in, trying to sketch it to look as round as it should be. This graph is continuous. It does continue left and right forever. So we want to graph in the wave that is to the left of the y-axis. So at negative pi over 2, it's at negative 1. At negative pi, we're back to 0. At negative 3 pi over 2, we're at 1. And at negative 2 pi, back to 0. And again, the graph continues. These boxes that are filled in here are the same ones from the other sheet. If you would like to copy the information here, you may do so. So what we're going to do now is we're going to graph the cosecant graph. To do this, we want all of the locations where sine is 0, the reciprocal of that becomes an asymptote. So we know that sine is 0 at 0, negative pi, 2 pi, and so on. So now we will have, asymptotes at those locations. So negative pi, negative 2 pi, pi, and positive 2 pi. Now, just to help us, as we graph this, we're going to make note of a couple of points because cosecant is the reciprocal of sine. We know that sine is 1 at pi over 2. We know that it is negative 1 at 3 pi over 2. We know that it is negative 1 at negative pi over 2, and that it is positive 1 at negative 3 pi over 2. So we're going to use this to help guide us as we graph our cosecant graph. Because it is the reciprocal, it will share the point where the value is 1. But instead of sine curving towards the x-axis, the reciprocal is going to go the opposite direction. So at each one of these points, looks rounded. It approaches the asymptote, but it does not touch. In this branch, we're at negative 1. And then at this branch, we're at positive 1. So this is what your cosecant graph looks like. If I draw in the sine graph just as a dashed line, you would see that it goes this way. So these branches of the cosecant graph also continue continuously from left to right, just as the sine wave does. Looking at the period of cosecant is the same as sine. Period is 2 pi over b, and it takes both branches. So one period is both branches. This is period equals 2 pi over b. Both branches are included. It isn't separate. Each branch isn't a separate graph the way tangent and cotangent were. We have relative maximums and relative minimums at these locations where the peak of each branch is. and they coincide with the maximums and minimums of the sine wave. So I will leave you to list all of those. Our domain and range are not continuous. They're not, it is not negative infinity to positive infinity. For each one of these branches, you have to list the domain and the range. And then we're going to do this in class with we've gone over how to do the algorithm to express all of these things rather than listing all of these things in a set. We can list the asymptotes here. Our asymptotes, I'll list those just as a continuous set for now. So our asymptotes are at negative 2 pi, negative pi, 0, pi, and 2 pi. Again, continuing. Intervals where the graph is positive. The graph is positive between negative 2 pi and between 0 and pi. Those are just two of the branches. So we'll have this pattern will continue. Negative 2 pi to negative pi. It's positive. And 0 to pi, it's positive. Where it's negative is between negative pi and 0, and between pi and 2 pi. Intersect. So this is your cosecant graph. On the next page, on the back of this sheet, I want you to do the same as you've done with the others. I want you to sketch both sine and cosecant on the same grid. Dash in the asymptotes with blue for the cosecant graph, and then follow the same pattern as before. Check if the general shape is the same, check it. In this case, it is not, so it's different, and then explain how it's different. The domain and range are different. The period is the same. So you could check that the period for both is 2 pi over b for both, and explain that that is because two branches are included. Amplitude, maximum and minimum values, we've listed those. Talk about whether they are different or the same. And then the expression for the values, this is what we're going to cover in class. Listing the zeros, there are no zeros for cosecant, so they are different. Cosecant has no zeros. It does not cross the x-axis at all. And then the intervals where they're positive or negative, are those the same or different? And then obviously the asymptotes are different because sine has no asymptotes. So finish filling in the rest of this page on your own based on the graphs, and we will move on to the next video where we look at cosine and secant. Thanks for listening.